to everybody once again. This is Dr. Atul Oak, and I'm going to take this course on microprocessor for computer engineering and allied branches. What you see is my brief profile before we officially start. And this is my start of the course. So this course is microprocessor for semester 4, computer and allied branches. It's a routine course. I can say it's a fundamental of computer engineering, because why your computer works, the big contributor is this subject, that is microprocessor. And we hear i3, i5, i7, Intel series of processors. That all magic is in this subject. Normal scheme you will find there is a theory which is 80 marks, that is the end same examination. Internal assessment in your college, you will be appearing for couple of tests carrying 20 marks. Term work, which carries 25 marks, the laboratory. There is no practical examination, and the total credits are 3 for theory and 1 for lab. Total weightage is 1 to 5. So normal subject like all other subjects, but this subject is on the top of COA, because if you see the last point at the bottom of the table, which I'm referring, the prerequisite is COA. Many concepts of computer organization you will require in microprocessor. I think today we will see how that reference goes in SEM 3. And of course, some fundamentals of C programming you will require as a prerequisite. I will suggest in this week, when we are starting, you read about some fundamentals of COA, typically the pipelined concept, the microcode program control unit, the hazards in pipeline, and the cache memory, because all these concepts we will require in microprocessor. There are 6 modules. It's an ocean basically, and I have a big challenge to cross this ocean in 30 hours. So I have made the lesson plan, which is already been shared, and 6 modules are there. We will follow a sequential approach, 1, 2, 3, 4, like that. And let's try to complete in around 30 hours. So approximately 14 sessions, 14 sessions, we will able to complete. That is the plan. What we are doing for the day. Already I started about my brief background. Many students are there with COA, so they are well aware. I have taught COA. In fact, I always teach COA and microprocessor. So I discussed about my brief profile, the look of the subject, the general plan, how we are going to fit it, and Today, our main focus for next around 2 hours is we will bring microprocessor in our discussion. We will identify why microprocessor is significant, where it is located. We will discuss concept of bus. We will classify different types of buses, the fundamental types. We will map it with a memory called RAM. This also you have studied in COA, the memory organization. And we will try to enter 8086 microprocessor with a concept of pipelined architecture. So that's the plan in session 1. Just to make you little familiar, you can see this is really an ocean because you are studying 3 microprocessors: 8086, 80386 DX, Pentium, and advanced version of Pentium, that is Pentium 4, which I'm not counting separately because small module is there. And I have read that microprocessor is the toughest thing designed so far on the earth. And such 3 microprocessors you are going to study in this subject. So let's start with microprocessor, and we will initially identify where exactly this microprocessor is located and how this microprocessor impacts our computer. So if all is good, then you can respond in chat box with a magic word YES. Whenever I want to test how much you are alert, if I'm reaching you, I will tell you to type YES, which means that all is well. And most of the communication we will do by chat box. You can unmute for any query or for any specific reasons, but avoid, because if all starts unmuting, then it will be a difficult situation. Okay, so time to go. If all is well, type YES in chat box. I'm audible, I'm visible, and my presentation is also visible. Okay, I can see many different combinations of YES. Looks good. Okay. Let's start with a question. Question is in front of you, and that question is, what is a computer? You are in computer engineering. Your subject is related to computer. Can you tell me what is a computer? This you have studied in COA also. So any quick definitions of computer in chat box? Let me see how many definitions you can provide. What is a computer? That is my question. The time is around 40 seconds. What is the computer? That's the question in front. And I'm looking in chat box for some good answers. Okay, Ayushi was there in COA. Computer is a device that performs arithmetic and logical calculations. Okay. I think Rishabh was also there. A machine which can operate arithmetic equations. Okay. I can see only 2 answers. What others are thinking? The definition is very simple. I'm asking what is a computer? Okay, let me go ahead. But yes, these are the correct answers. The Ayushi and Rishabh, they have communicated. This is what is a computer. Yes, look-wise, this is a computer. Just adjusting my screen. Give me a second. This computer you see in our day-to-day life, which is a typical desktop computer. And this computer is called Raspberry Pi, which is a small board computer. What is a computer? We say that computer is electronic machine which processes the data very fast and generates valid result. So very simple and sweet definition in front. It's an electronic machine because you can see there are a lot of ICs visible here. This is a small IC and it processes the data. It does a lot of calculations like one answer in chat box, and it does it at very high speed, much faster compared to human, and we get accurate results. And we know computers are everywhere. There is no field which is without computers. We have computers in banking, in education. We are communicating. We are doing teaching, learning through computer. And of course, industry. There are more computers and less humans nowadays. The question is, I know what is a computer. I know why computer. But what is the minimum requirement if I want my computer to work? So if I want this computer to be a working computer or this Raspberry Pi as a working computer, what is a minimum requirement? Can you tell me in chat box, what is your answer? What is minimum requirement for any computer? I'm talking at very fundamental level. I'm not talking about big words like software and all. What is minimum requirement for working of computer? That is my question. Okay, I can see one answer from Rishabh, that is processor, RAM, storage. Okay, that looks good. Input, output, very good, perfect. Yes, anybody else who wants to contribute? Boolean language, that's great. Ishan has added some more inputs. Okay, power supply, okay, good. ALU, memory, IO, CPU, okay. Last 10 seconds if you want to add. Okay, so these are all correct answers. So let's put it all together, okay? What you have contributed. Technically, if this is my computer, let's take Raspberry Pi, okay, as a reference. Then my computer should have some mechanism to get the data from real world. And that hardware, it's called input unit, like a keyboard. You can see it's appearing, keyboard. And we read data via input unit. So if we take any computer, one very fundamental requirement is a hardware called input unit or keyboard where we read the data, okay, like 15, 20 and dot dot. Second fundamental requirement is where I'm going to see the data, because my definition was it's an electronic device which processes the data and generates valid results. So how my data will come? It will come via hardware called input. How my results will be visible? It will be visible through a hardware called monitor. So every computer will have some input like a keyboard and output like a monitor. Hereafter, I'm going to call input output as IO. This is one word now you have to remember. IO refers to input output, like keyboard and monitor. Of course, for this Raspberry Pi, I have to connect keyboard, I have to connect monitor, because you must have seen computers based on the Raspberry Pi. I know how to get the data in my computer. I know how to see the data on my computer. But my definition, if you remember, was it's a device which processes the data. Now, who is going to process the data? Who is going to perform calculations? Who is going to do decision making? Who is going to generate valid result? That hardware is called CPU or microprocessor. That is our subject. So in this subject, we will study what is the magic inside this box called central processing unit or microprocessor, a small device which forms brain of the computer, BRAIN, because in school days, we always make such statements that CPU or microprocessor is the brain. So we are going to study that brain in this particular subject. So our subject is visible. So you know where is a microprocessor. I know how to read. I know how to process our subject. I know how to display. But there is a requirement that I need to see my data occasionally, maybe after 2 hours or maybe after 5 minutes. And for that, we need one hardware. That hardware is called memory. And that memory is called RAM, that is random access memory. Okay, same memory that you have studied in detail in COA, the memory organization. Of course, some brush up we will do in this subject so that your understanding will be clear. So 4 major hardware blocks in your computer: read, display, process, and store. Now slowly we are moving into the subject, okay? Because this start we normally do in COA also. This is a common start if you want to enter COA or if you want to enter microprocessor. Now my question is, can you tell me what is missing in this particular diagram? Can you identify? No component is missing, okay? All devices, all hardware requirements are visible. But still, there is something missing. Can you tell me in chat box what is missing in this diagram? Any thoughts? Excellent. So what Rishabh is referring is correct. Let me make it to the specific point. Basically, you will read from input device and you will provide that data. Like here I have said read 15 and 20. And here I have said compare or add 15 and 20. Who will do this? Microprocessor. But how this data will reach my microprocessor? There is a gap here. Same way, my processor will add these two values or compare these two values, but whatever result my processor will generate. Now I will use a word microprocessor. How that result will go to RAM or the output device, because here there is a gap and here there is a gap. So essentially what we require between these four fundamental hardware blocks is a communication. Because without communication, your data cannot be shared. And that communication we do in computer with microprocessor using a concept called bus. Observe it. So essentially what we need between these blocks is a technique called bus. Now we are in microprocessor. Have you heard this particular term in your colleges? Because your colleges have started. I'm assuming you are in marathon and you must have heard this particular word. If you have heard this particular word, type Y in chat box. Have you heard BUS? Let me see how many of you have heard this particular word, BUS. Okay, now this is a very simple question. So I think everybody should respond to my question. How many of you have heard this particular word? Excellent. So I'm happy you are aware of this word. Now let's explore. What is a bus? Bus is a communication between different functional blocks of a computer. Bus is the group of metallic conducting path or wires to share data between two hardware units of a computer. I repeat, bus means group of metallic conducting paths. That means conductors, copper conductors or wires, because bus sometimes comes outside, to share, to communicate data between different functional blocks. So what you see, some arrows are visible in this diagram. They are not decorations, but that is a bus. So this is a bus. This is a bus. And this is a bus. Like in our day-to-day life, bus is for transportation of people. In computer, bus is for the transportation of data from input to microprocessor, from microprocessor to memory, from microprocessor to output. And if you see very carefully, you will find one more observation. This microprocessor is communicating to every other device. See, this microprocessor is communicating to keyboard. This microprocessor is communicating to the output device. This microprocessor is communicating to memory. That's why it is called central processing unit. So there is a logical reasoning Why it is called CPU? Because it is at the center and all other devices report to your microprocessor. It's a king of your computer. Okay, your computer has two kings. One king is a microprocessor and second king is an operating system. Okay, let's move on. यहां तक अगर आपको कुछ क्वेरी है तो आप पूछ सकते हो. आई एम गोइंग टू टेक योर क्वेश्चंस इफ यू वांट टू रेज योर क्वेश्चंस. So my very simple question is coming in chat box, and that question is any questions. If you have any questions, you can raise. If you don't have any questions, type NQ in chat box. NQ का मतलब है no questions. I will go ahead. Any questions that you want to ask? Okay, there are no questions. Let's move on. Okay, that's fantastic. Let's move on. One point I just want to add. You are aware that we are crossing a big ocean, okay? That ocean is microprocessor. So dictation of notes is not possible for me. I wish that I can give you best notes possible, but time is a constraint. So my suggestion is you appear these sessions with proper notebook, pen. My pace is such that you will able to note important points, make your own notes for your reference. All soft copy of these subject you will get from our app. Already all modules are uploaded or they are under revision, slight revision. So all these materials you will get. But I always say you try to get something more from these sessions. So your examination and your further engineering will be great. Just a gentle reminder. Okay, let's go on. In your computer, there are three types of buses. Can you tell me what are three types of buses? Just a guess, or from your college, because your college is, like I said, it's a big marathon. Can you tell what are the three basic types of buses? Anybody? Okay, I can see two buses from Rishabh. I can see two buses from Sahil. I can see exactly three buses from Ayushi. That is right. Okay, so there are three buses, and those three buses are called e-address bus. We call it as AB. The control bus, we call it as CB. And data bus, we call it as DB. Okay, in next around half an hour, we are going to understand how these buses are used inside a computer. Because if that clarity is there, then we can enter 8086 microprocessor. Okay, because in features, you will find these words, features of 8086. These words will be visible. Okay. Like I said, we will understand what is the function of these buses, the address bus, the control bus, and data bus. And combination of these three buses is called system bus. So address bus with control bus with data bus, we call system bus. So what you see here is a system bus. This is a system bus. This is a system bus. This is also a system bus because everywhere there is an address bus, data bus, and control bus. You cannot show separately. Your diagram will have more arrows than the number of blocks. That's why we normally put these three in one called system bus. This is a system bus, and system bus. Okay. There is no computer anywhere in the world which works without these buses. This is just a fundamental requirement. जैसे human needs oxygen and water for day-to-day life, your microprocessor needs address bus, control bus, data bus, combination, system bus. Now let's understand how and why. In exam, you might get a question with a very less probability. What is a bus and what are different types of buses? Okay, we should map with exam also. The probability is around 5% in your final exam. What is a bus and what are different types of buses? Okay. Let's explore it. Okay, we are moving one step about these buses. Now, there are some observations, okay, and these observations are very general observations because I want to take you further. Do you agree that all blocks of the computer are hardware devices? It can be input device, it can be a memory, or it can be a microprocessor. So your microprocessor is a hardware. Your subject is 100% hardware, but still there is a programming. Okay, you must have entered labs and you must have started assembly language programming. That means all fundamental blocks of the computer is basically hardware. So if I go back, then this is a complete hardware. This is a complete hardware. Here is my question. Can my hardware will work directly in the computer? Is it like if I connect keyboard, if I connect monitor, if I connect RAM, and if I take microprocessor, then my computer will work?
No.
Your opinion. You have to say yes or no in chat box. What do you think? Will your computer will work only with hardware? Yes or no in chat box. Okay. No, 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 no. Okay. Okay. That's correct. It's big no, no. That is right. But can you tell me why in chat box? Why not? Why your computer cannot work just by hardware? Yes. That is what is a word I'm looking. I think Rishma has shared. It's a software. Okay. Now be very alert. Essentially, your hardware cannot work alone. You need software to run hardware. I again repeat, you need software to run hardware. Understand this very carefully. I will map it with actual example also.
So because hardware and software are interdependent, right?
Yeah, that is right. Okay. The point is, we need hardware to run software. Am I correct? No, we need software to run hardware. Question is, how you are going to get this software? Can you tell me quick answers in chat box? Try to communicate in chat box because that is an effective way. What is the only way to get your software? Quick. मेरा हार्डवेयर बिना सॉफ्टवेयर से रन नहीं होगा, तो मेरा आगे का क्वेश्चन है सॉफ्टवेयर कहां से आएगा? Any answers? Quick. Okay, one answer is through operating system. It's a good attempt, Tarun, but better answer possible. Yes, programming. Again, that word I have found from Rishma. That is programming. Now let's join all these dots together. Essentially, how we get software? We get software by writing a program. So any software in your computer is a program. Either you make it or you get it. That is where I start teaching programming languages. Any software is a program. Either you get it, like operating system, you get it, or you make it. Applications, you make it. But what you need is a program. That's the reason in this subject, there is a programming part. But that programming is slightly different from your semester 1 and semester 2. It's not C programming or Java programming or Python programming. It's a low-level programming called assembly language programming. Don't worry, that we will study separately. I just want to make you ready for it. You should be aware how it is going. Okay. What's the program? Very simple. They are the instructions, group of instructions to perform some task. Okay. Summary. All your computer blocks, devices are hardware, including microprocessor, our subject. Just hardware is necessary but not sufficient. You need software to run hardware. To get that software, you need a program. You need skills of programming. And we develop program, we write program as a group of instructions to perform some task. That means your computer needs hardware as well as software. Your computer is like husband and wife, hardware and the software. Okay, they will quarrel, but they are the necessity of life. That is what is your computer. Okay, now let's go ahead and explore something more. यहाँ तक अगर आपको कुछ query है तो पूछो. Check it out. If you have any questions, okay, I will take your questions. Check it out. Chat box में communicate करो. मेरा थोड़ा volume जो है वो कम है. Okay, so chat box में I should not miss anything. That's why. Check it out. Any questions? नहीं है तो NQ type करो. Please respond. We have discussed for around 40 minutes. Any questions? Okay, and I want responses from everybody, okay? Because it's basically a teamwork. What we say, it's a team who wins and it's a team who loses. So be together anyway. Okay, हम लोग अभी आगे चलते हैं. Now we will map the buses, okay? Here we go. Now have a complete concentration, okay? If you are doing something parallel task, stop it and understand this concept. We are moving towards 8086 microprocessor with these fundamentals. What you see is a blue box, okay? That is called as memory, called RAM. And on the other side, you will find that there is a microprocessor and there is a memory called RAM for our reference. Okay, and this particular blue box is a memory called RAM, which I'm going to explore. Because I want you should have a very clear understanding of buses. Then only microprocessor subject you can think of. Okay. And let us take a small program, okay, which you will find on the other side. You can see there is a program, I1, I2, I3. These are all instructions in the program. Okay, we are not worrying whether it's a C program, Java program, Python program. It's a program, okay, having 50 instructions. Now you have to answer my questions in chat box, okay? And I'll be developing the concept. I repeat, this is my microprocessor, our subject. This is a memory called RAM. This is a program, any program, C, Java, assembly, okay? Question 1. Can you tell me who runs your program? Answer in chat box. Which part of the computer runs your program? आप जब भी बोलते हो मैंने प्रोग्राम एग्जीक्यूट किया, कौन एग्जीक्यूट करता है? Okay, I can see answer, that is processor, that is correct. CPU or processor, two answers are correct, Tarun and Rishma, okay? Both are correct. Aditya is correct. So who runs my program? It's a processor. My second question. Can you tell me where we store the program? Where we store the program? Correct, RAM. Okay. So those two blocks are visible. Observe it. Perfect. So all answers are correct. Person who runs the program and person who stores the program. Okay. When you are running, that is RAM. Okay. Now let's take this RAM in detail. Okay. To understand the concept of buses. In 10 minutes, you will understand what is the significance of bus and you will never forget lifetime. So let's explore memory. Typically, your memory called RAM has billions of such locations called memory cell. Observe it. Okay, you can see there are some rows visible. Okay, this is a row, this is a row, and like that, there are many rows. Such rows are called memory cell, and such billions of locations are there because our RAM nowadays is in GB, okay, gigabytes. Okay. Typically, every memory cell can store 8 bits. Observe it. Okay, you can see there is something called D7 and there is something called D0. Okay, D7 to D0. D stands for data. It can be an instruction, it can be a value, general word. Okay. A typical memory cell can store 8 bits. That means zeros and ones because everything in computer is in binary at the end. Every memory cell has address. Observe it very carefully. Okay, like this memory cell has address 00000H. H का मतलब है हेक्साडेसिमल. अपने COA मॉड्यूल 1 में नंबर सिस्टम्स पढ़ा था. ओके, उसका हेक्साडेसिमल. So every location has an address starting from 0000H and it goes sequentially. This is 1, this is ... ये कुछ random address मैंने assume किया है and it goes on. Okay. Now comes mapping. You will agree that this particular program we always store in a memory. Okay. That we have started, in fact. When you run any program, it is in RAM. How a processor will understand where in the memory your program starts? The answer is address bus. Address bus are the group of wires, metallic conducting path, which carries this information. Observe it. The one which I am referring by mouse pointer, the address. So all your address location of memory, you communicate via address bus. So address bus tells which location of RAM, which IO device you want to access. It carries address. It carries information of location. It tells microprocessor where to go. The answer is address bus. Let us assume processor knows through address bus, I want to go at this location 10000. Okay, I'm just assuming one value. So processor will reach this location through address bus because this value you carry on address bus. Okay, so there are multiple lines. My word is group of lines, group of conducting paths, group of wires. So there are many. So if my processor reach this particular address, okay, this address, my processor reach. How my processor will understand whether I want to read this particular location or write this particular location? Because your memory is a Boolean device. You know what is the meaning of Boolean. Your memory supports two operations, read and write. So how processor will understand at this location you want to read or you want to write? We need control bus. Control bus carries timing and control signals like read, write, all these signals you will communicate via control bus. Okay, so control bus tells which operation you want to perform. Do you want to read? Do you want to write? Let us assume read. So address bus tells go to 1000 or 10,000. Control bus tells you read using a control signal. And whatever you read, okay, I will read a byte because I already said every location stores 1 byte. So what you read is a byte, D7 to D0. D7 is called MSB and D0 is called LSB, most significant bit, least significant bit. So what you read is 1 byte. This you will read via data bus. So data bus carries actual instruction, actual data between memory and processor or processor and IO devices. And these three buses works together. It will never happen that only two buses are sufficient. They are always in sync, and that is called system bus. The address bus, where to go. The control bus, what you want to do, like read. Data bus, actually read and communicate the data. That is called system bus. That's why any computer anywhere in the world requires three buses: the address, data, and control. Check if you have any questions. We have mapped these buses with their functionalities. Check it if you want to raise any question. My question is, once again, any questions? Please check it out. अगर कुछ पूछना है तो through chat box you ask. We have completed around 55 minutes of discussion, and we have discussed about buses, types of buses, what they do, and of course brought microprocessor. मैंने ऑलरेडी बोला है, अगर आपको क्वेरीज नहीं है तो टाइप NQ. मुझे पता होना चाहिए कि आपको क्वेश्चंस नहीं है. Okay, I will summarize it. Okay, I will not explain because we are running a race against time. but I will summarize it, which you will understand quickly. Okay. Anyway, something more I'll be talking further. Technically, this is my microprocessor and this is my memory where I store the program. So whatever program we have taken as a reference, it goes in memory called RAM. That memory has billions of locations. Location 1, 2, 3, dot, 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 and so many. Every location has address. Okay, it's a unique address. It's not duplicated. Okay, starting from 0 going up to max. Question is how my processor will know where in the memory my program starts or where in the memory my data is available, because there are billions of locations. That information we carry using address bus. So address bus carries information where to go in memory or where to go to input device or where to go to output device. Let us assume my processor understands I have to go to a location 10000H for hexadecimal. Of course, through address bus. The second requirement is, do you want to read this byte or you want to write a new byte? That is called control. Read, write. That you carry on control bus. Control bus carry timing and control signals. Okay, we will see in 8086 what are those signals. Here we are little general. Let us assume through control bus, processor understands I want to read. What you read is a byte, D7 to D0, MSB to LSB. That byte you will communicate, you will read through data bus. So address, control, data, ये sequence में आपके buses use होते हैं computer में. I don't know, but if you are carefully listening to me and you are doing single tasking, you will agree that when I introduce types of buses, I have shown in a particular sequence. सबसे पहले एड्रेस बस, उसके बाद कंट्रोल बस और उसके बाद डेटा बस, because in this sequence your buses are used. Where to go, identify the location. Do you want to read write operation, control, and actual instruction or data, that is data bus. That's the sequence. Okay, now let's move on. Now we will enter our first microprocessor 8086. Okay, this is your 8086 microprocessor, what you see on my presentation. It's an Intel microprocessor. The age is around 46 years. 78 is the year when this processor was invented by Intel. And it's a legacy processor because most of the microprocessors that we use today, they are evolved from this 8086 as the basic model. I don't know, but if you are little careful about your software installations or any type of software or game you are installing, operating system you are installing, you get one prompt which type of platform you want to go for. There is one choice 80 cross. 80 cross is basically 8086. Okay, that's the significance. Very simple look what you see. And let's start with features. Okay, अभी आपको अच्छे से ध्यान देना है क्योंकि वापस बसेस का कंसेप्ट यहाँ पे रिपीट होने वाला है. Okay, let me check how many of you are alert. If all is good, please type YES in chat box. If all is good, you type YES in chat box. Okay. At least many of you are alert. I can see. Okay. Looks good. Let's move on. 8086 microprocessor is a 16-bit processor. It has 16-bit data bus. You can see D15 to D0. And it has 20-bit address bus, A0 to A19. Okay, you can see your processor starts with buses. That is the reason last 1 hour is significant. I repeat, 8086 is a 16-bit processor. जब भी हम लोग बोलते हैं मेरा प्रोसेसर 32 बिट का है या 64 बिट का है, तो essentially वो रिफ्लेक्ट करता है डेटा बस. Okay, so it's a 16-bit processor, 16-bit data bus, D15 to D0, and 20-bit address bus, A19 to A0. Okay. Now this processor supports maximum memory of 1 MB. Now here there are some calculations. Okay, you need to be very alert. Question is, how we find if my processor is 8086, how much maximum RAM I can use? Like here I have said maximum RAM is 1 MB, okay, 1 megabytes with 8086. It depends on address bus, understand? Okay, your address bus defines what is the maximum RAM you can use with your processor even today. Okay, and there are some calculations. Now for that, what I will do, I will shift our discussion to Microsoft Word. Okay, एक फाइल मुझे ओपन करना है जिसमें मुझे आपको सिखाना है कैलकुलेशन पार्ट. ओके, स्टार्टिंग में मैंने वो ओपन नहीं किया है, तो जस्ट गिव मी अ मिनट. In fact, less than that, I'm just opening that file. Okay, I need this file for mapping how it is 1 MB. Okay, ठीक है. Now all is good. Observe it. I hope it is readable क्योंकि मैंने उसका FONT sufficient रखा है. Okay. In front of you there are 3 values, और ये मैंने COA में भी आपको बताया था जब भी मैंने कैश मैपिंग टेक्निक्स पढ़ाए थे, तभी मैंने ये वैल्यूज आपके साथ कम्युनिकेट किया था. Those who have attended COA. 2 raised to 10 is 1 KB, 2 raised to 20 is 1 MB, and 2 raised to 30 is 1 GB. Okay, these 3 values you have to remember forever. Okay, why? Reason is maximum memory supported by any processor like 8086 or Pentium is given by M equal to 2 raised to 8. This formula also we have discussed in COA, cache mapping techniques. Of course, those who are new, for them I am explaining. M is equal to 2 raised to 8. This also you have to remember forever in microprocessor. M indicate maximum size of memory like RAM, and A indicate number of address lines. So if I go back to my presentation, okay, second point, then you will agree that this particular value comes from address bus. That's why address bus is very significant, because it directly tells how much RAM is supported. Okay, let's continue with the calculations. Okay, so you will understand better. Okay, I'm moving back to Word. Okay, here we are. So I hope you must have noted these three values, and you must have noted this simple formula m equal to 2 raised to a. This we need in memory interfacing. Okay, you listen my statements carefully. There is a module called memory interfacing. When we started in the evening, I have shown you the modules, chapters. And memory interfacing normally comes in exam as a design question carrying 10 marks. In that, we need this particular reference. Your design starts with this. Okay, so you be very alert. Okay, I will scroll. Okay, मैं पीछे जा रहा हूं. Like Rishabh has said to show this conversions. Okay, conversions नहीं, values. ये आपको याद रखना है. इसका पिक ले लो या लिख लो. ठीक है, I think you have noted. ठीक है, आगे जा रहा हूं. ये फॉर्मूला है. ठीक है, नाउ लेट्स डू द कैलकुलेशन. This is a question. If microprocessor have 20 address lines, how much memory is supported? This is so simple. Observe it. M equal to 2 raised to a. My processor is 8086 with 20 address lines. So 2 raised to 20. And just now I have shown you one table. 2 raised to 20 is 1 MB. So straight away, your 8086 microprocessor supports 1 MB of maximum RAM. Okay, let's do one more example. Observe this. This all I will share. Okay. What is the size of maximum RAM used with a processor of 32-bit address bus? Matlab, what we used in day-to-day life. They are all 32-bit address bus or little more. M equal to 2 raised to a. M equal to 2 raised to 32. Go to the school dates. Apply law of indices. Split this 2 raised to 32 as 2 raised to 30 into 2 raised to 2. Simple law of indices. 2 raised to a, 2 raised to b is equal to 2 raised to a plus b. Okay, मैंने सिर्फ split किया है. क्यों किया? Because I know 2 raised to 30 is 1 GB from the table. And 2 raised to 2 is 4, which is a constant. So 4 into 1 GB is 4 GB. So the maximum RAM used with this processor is 4 GB. That's the reason today we talk about RAM about 4 GB, 8 GB and ... So all these values are actually coming from this formula. So when I say that my computer, my laptop has 4 GB, it is coming from this formula. When I say that my computer, my laptop is having 8 GB, it is coming from this formula. Big contributor is the address bus. How many address bus lines are there in your microprocessor? That defines size of maximum memory. Check if you have any questions. If no, I will go ahead. Check it out. Any questions? Okay. No questions, no questions, no questions. That looks good. Okay. Just checking our time progress. Okay. I'm going ahead. Okay. I'm going with features of 8086, where I have left. Okay. Here I am back to features. Okay. I hope now it's clear how this 1 MB is calculated. It's a simple calculation. It's a hardware. So your microprocessor is available as integrated chip, that is IC, with 40 pins. Okay. It is called DIP. That means this look is called DIP, dual inline package. 20 pins one side, 20 pins other side. Your microprocessor works with heart called clock frequency. Okay, the heart of your microprocessor is a clock frequency. Why you need that clock frequency, you will understand in our next discussion. Estimated time is around 10 minutes. But 8086 microprocessor works with 3 clock frequencies, the 5 megahertz, the 8 megahertz, and 10 megahertz. Okay, simple to remember. 5 megahertz, 8 megahertz, and 10 megahertz are the clock frequencies supported. This is a processor which uses a technique called pipelined architecture, which we will be immediately going now. This processor has a technique called memory segmentation, which we'll be doing along with architecture. These are all proposed discussions. I'm just listing as a feature. Your processor has a memory management called memory banking. Again, we will be discussing. These are all features. And your processor, you can program using assembly language instructions. It's called low-level programming. Again, we'll be discussing. In all major features of your 8086 processor I have listed. And now we are going to explore pipelined architecture, memory segmentation, memory banking in coming 1 and 2 sessions. Today and next, we are going to complete architecture, okay, of 8086. Anyway, let's move on with pipelined architecture, okay. What you see as a title of presentation is your COA, von Neumann model. You know who runs my program? It's CPU or microprocessor. You know which hardware stores the program under execution? It's RAM. This already we have discussed. And now the question comes, how my program is executed? How exactly my program runs? What is the technique to execute the program? Now this is little critical. Reason is, if you are good listeners, when I discuss memory model, I have clearly said your program is executed by microprocessor. And during execution, your program is stored in RAM. That means the person, the hardware which runs your program cannot store the program. And the person or hardware which stores the program cannot execute the program. So this question is relevant because there is a gap. Processor can execute, cannot store. RAM can store, cannot execute. Then how my program will be executed? Because it is in RAM, which cannot execute the program, not in processor, which can execute the program. So if you have understood this playing of words, then the answer is fetch, decode, and execute. So if you remember your COA, the von Neumann model, we have discussed any program you always run using 3 steps: the fetch, the decode, and execute. Now, how we do this, the fetch, the decode, and execute? There are 2 ways. One way, let's go for it. Let us assume we have a program. Okay, I'm just bringing all essential elements. Let us assume we have a program with some instructions. Okay, 50 instructions. Who executes this program? Microprocessor. Where you store this program? RAM. Okay, and they are connected via buses. That is what previously we have discussed. Now this all is meaningful. Again, I repeat, we are going into 8086 architecture. Let us assume I have a program with 50 instructions. Assume those instructions can be in C language or in assembly language or in Java language. Okay, because finally all comes in binary. This program is executed by a processor 8086, and this program is stored in RAM. One way to run this program is, you can see there is a time axis appearing, okay, horizontal axis. You read one instruction from the memory like I1 and get it into the processor. That is called fetch. Okay, you can see there is something called F1 appearing. That means fetch instruction 1. Okay, ये भी अपने COA में किया है, the last module, pipelined concept, advanced concept. But anyway, let's now talk separately for 8086. So what you do, this instruction 1, you read from memory into the processor. That is called fetch. Okay, fetch instruction 1. Then you decode and execute instruction 1. You can see E1. Okay, F stands for fetch, E stands for execute. Basically decode, execute. Okay, थोड़ा डायग्राम को सिंपल बनाने के लिए decode, execute I am representing by E. So you fetch instruction 1 into the processor. You decode that instruction. Decode means find out what is the meaning of the instruction. Scanf hai, printf hai. That is what is decode. And then you execute. That means you run that instruction. That is called E1. And do it for all instructions sequentially like this. Observe it. Fetch instruction 2, decode, execute instruction 2. Fetch instruction 3, decode, execute instruction 3. Fetch instruction 4, decode, execute instruction 4, and so on. This approach is called non-pipelined architecture. See the terminology. Terminology is non-pipelined architecture. So how your processor is designed? Your processor is designed as a sequential processor. You fetch, decode, execute, and do it again and again. Can you tell me, if you are listening to me carefully, what is the problem of this approach? Any thoughts? in chat box. क्योंकि इंटेल का जो सबसे पहला माइक्रो प्रोसेसर था जिसको हम लोग बोलते हैं 8085, जो हम लोग ने हमारे इंजीनियरिंग में पढ़ा था 8085, that microprocessor was a non-pipelined architecture, what you see, but it has a disadvantage. Can you tell what is the disadvantage? Okay, I can see couple of responses, but I'm expecting more responses. You should participate. Okay, it is not a monologue, it has to be a dialogue. So it might happen your answers are wrong, but it's okay. So the big problem with this particular approach is, first of all, it is a sequential process, so it is going to take more time. Anything which is sequential will take more time. So the time to execute your program with 50 instruction will be more, because you will do one by one. Second disadvantage is, if you observe and listen carefully, when you are fetching instruction, here you are fetching instruction, here you are fetching instruction, here you are fetching, here you are fetching. When you are fetching instruction, there is no major work for your microprocessor, because fetching refers to memory. So your processor has to wait till your instruction comes. Then you can decode and you can execute. So the resource utilization, timing utilization of your microprocessor is not good, because processor has to wait. If I get instruction, then only I will decode and execute. If I get instruction, then only I will able to decode and execute. That's the reason Intel modified this entire architecture from 8085 to 8086. 8085 non-pipelined, what you see, to 8086, the pipelined architecture. What is the thought? Understand, we are moving in 8086. Thought is, start with time. So you can see horizontal axis, time axis is visible. You cannot run away from von Neumann model, understand? Okay, it's a great contribution in computer engineering. What we do on computer is because of von Neumann model. So you will talk fetch, decode, execute for next few years. So we start with fetch. Okay, observe it. Your processor will fetch instruction 1. But now there is a catch, which you have to hold. The catch is, when your processor is decoding and executing instruction 1, simultaneously your processor will fetch instruction 2. See this carefully. Again, I repeat, when your processor is decoding and executing instruction 1, at the same time, T2, observe it, your processor will fetch instruction 2. When your processor will decode instruction 2, execute instruction 2, your processor will fetch instruction 3 simultaneously, T3 I'm talking, and it will continue. Okay, we will take 4 instructions only. So you will go for decode, execute instruction 3 and fetch instruction 4, where there is overlapping, see my words carefully, overlapping of fetch and decode execute. Overlapping का मतलब है simultaneous process. There is a simultaneous fetch and decode. This approach is called pipelined architecture. See the second word, a pipelined architecture, and we are in 886. So this is a first microprocessor which is a pipelined architecture. Now the question is, what is the benefit? Benefit is visible on your screen if you are with me. Benefit is, you must have noted, to complete execution of 4 instructions, I need time up to T8. Observe it. Okay, T1, T2, T3, T4, T5, T6, T7, T8. But if I use pipelined architecture, then my execution of 4 instruction gets completed in T5, T1, T2, T3, T4, T5. That means I'm saving my time. T5 is much less than T8. That means my program is getting executed faster. That means my processor is better in performance. That means I should accept pipelined architecture. That's why today also we use pipelined architecture. Of course उसमें काफी सारे improvements है जो आगे के प्रोसेसर में हम लोग देखेंगे. Okay. You must have noted there is something called two-stage pipeline. See this. Okay, now let's understand what is that. This is the minimum pipelined architecture possible. चालू होता है 2 स्टेज से, फिर वो होता है 4 स्टेज, 5 स्टेज, 10 स्टेज. Okay. Now why 2 stage? The answer is, if you observe very carefully here, simultaneously I'm doing 2 tasks. I'm doing fetching and I'm doing decoding and execution. That is called 2-stage pipeline, because there are 2 tasks which are happening simultaneously. So how many tasks you do simultaneously? That is called 2-stage pipelined architecture. Okay, and this architecture is used in 8086. What you see is the architecture of 8086. Now here we will take some time, because there are many elements we have to understand in this diagram. And of course, a technique called memory segmentation. Okay, but let me map previous discussion with this architecture. It is true that your 886 processor is a 2-stage pipelined architecture. First stage, okay, let me use my marker here. Okay, now I can use this marker. You can see this is my first stage, okay? And this is my second stage. Okay. First stage of your 886 processor is responsible for fetch. Observe it. And second stage of your 886 processor is responsible for decode and execute. The stage which is responsible for fetch, it's called BIU. Observe it. It stands for Bus Interface Unit. BUS, Bus Interface Unit. That is a full form of BIU. This is responsible for fetch. How we will see now in detail. And second stage, which is responsible for decode and execute, it's called EU, that is execution unit. So execution unit of your 8086 will do decode and running of the instruction, and BIU will do fetching of the instruction. That is how your processor is designed. So you will agree that entire von Neumann concept is implemented in this architecture. The only thought is who will do fetch and who will do decode execute. Can you tell me in chat box who does fetch in 886? What is the name of the unit? मैंने अभी आपको बताया. Let me test how much you are listening. Which part of 886 performs fetch? Can you type in chat box? BIU, that is right. So the most fastest answer is given by Mitesh, and now it is correct. And can you tell me which part of 8086 performs decode and execute? Of course, remaining, that is EU. Okay, that's why there are two logical parts in 8086 microprocessor: BIU, which does the fetch, and EU, which does decode and execute. Okay, now we will study in detail the architecture of 8086. Okay, यहाँ तक अगर आपको कुछ query है तो can raise your questions. Okay, we are in architecture of 8086 and we are at 8 o'clock. So 1 hour 30 minutes we are working for microprocessor. So you can breathe, you can think, and if anything you want to ask, you can raise the question. My question is, any questions? Please check. Now let's map with your examination. This can be a 10 marks question in your examination. What we are now starting. Explain architecture of 8086 microprocessor flat, and it's a big one. So today we will be starting with one part, that is BIU. Okay. No question. So I will go ahead. Let's start with BIU. Okay. Now let me bring some more diagrams in our discussion. This is diagram 1 and this is diagram 2. Okay, just for the reference. What you see in dotted line, okay, I am hovering my mouse on those dotted lines, is your architecture of 886 microprocessor by Intel. So this diagram I have taken directly from Intel manual. All credits goes to Intel. I'm using it for my teaching. What you see at the top is a memory called RAM. You can see memory interface. Interface का मतलब है connection. Okay, so this is a memory which is connected with your processor 8086. ये जो dotted है वो आपका 8086 processor है और ये आपका RAM है. Okay, अभी वो symbols वगैरह वैसे ही रखे हैं क्योंकि Intel का एक copyright diagram है. Okay, तो उसमें no changes are possible. So this is my RAM, and let us assume we have stored some program in this RAM with instructions I1, I2, and so on. Okay. My 8086 BIU will go to memory, follow my mouse pointer. Okay. Of course, that memory is RAM. It will read instruction 1 and it will store that instruction in a facility called instruction queue. Observe this carefully. This box, it's called instruction queue. Instruction queue. Okay. How? Like this. See this carefully. Okay. There is a flow which is visible in red color. So your BIU, bus interface unit, will go to the memory called RAM. It will read instruction 1 and it will bring this instruction from RAM into a facility called instruction queue, whose size is 6 bytes. You must have noted there are numbers 1, 2, 3, 4, 5, 6. So this indicate size of this instruction queue is 6 bytes. So up to 6 bytes, you can fetch the instruction into the queue. Maximum up to 6 bytes. Then your BIU will fetch instruction 2 from memory RAM into this instruction queue like this. Observe it. So essentially you can see a small diagram aside which indicate which instructions you are fetching. So your BIU will fetch instruction 1, then it will fetch instruction 2, then instruction 3, and so on. Okay. Now let's understand how this instruction queue works. Okay, because that is the main component of this particular BIU. You can see in BIU, there are 3 main components, number 1, number 2, and number 3. Currently, we are in instruction queue. Let's understand how this instruction queue works. What your BIU does, bus interface unit of 8086, your BIU will go on fetching instruction 1, instruction 2, instruction 3 into this queue. And your EU execution unit will take instruction from this queue. So you must observe my mouse pointer carefully. So BIU will fetch instruction 1 and EU will take instruction 1. BIU will fetch instruction 2 and EU will take instruction 2. Of course, for decode and execute, because you know EU performs decode and execute as per this small diagram or our discussion. Okay, इसका मतलब ये है, when this instruction 1, okay, when this instruction 1 is taken by EU, this instruction 2 comes down. यहां पे इंस्ट्रक्शन 2 आएगा. जैसे ही ये इंस्ट्रक्शन 1 EU ने ले लिया डिकोड एग्जीक्यूट के लिए, तो ये जो इंस्ट्रक्शन 2 है वो यहां पे नीचे आएगा और ऊपर जो इंस्ट्रक्शन 3 है वो यहां पे आएगा. That means your instruction flow via this queue. जैसे अगर एक इंस्ट्रक्शन यहाँ पे है 6th पोजीशन पे, तो वो 5 पे जाएगा, 4 पे जाएगा, 3 पे जाएगा, 2 पे जाएगा, 1 पे जाएगा, एंड देन इट विल गो इन EU. So it's a flow of instruction. Just like a water flow, this is a flow of instruction. That is called pipelined architecture, because this queue is like a pipe. And what it support is a flow of instruction, and that way this architecture is called pipelined architecture. उसका एक लॉजिकल रीजनिंग है जो यहाँ पे विजिबल है, व्हाई इट इज कॉल्ड पाइपलाइंड आर्किटेक्चर, क्योंकि क्वेश्चन इज वेरी बेसिक कि व्हाई यू कॉल एज अ पाइपलाइंड आर्किटेक्चर. It's because of this structure we call it as a pipelined architecture. It's a closed structure queue, and in that your instruction flows from top to bottom just like a water flow. That is what is pipelined architecture. Okay, let me again repeat. क्योंकि sometimes you get a question in your exam, explain instruction queue in 8086 processor carrying 5 marks. So you have to only explain instruction queue. So let me again quickly go through it. I said DIU of your 8086 processor will go to memory called RAM. It will fetch instruction 1, it will fetch instruction 2, and store it in instruction queue, which is 6 byte. Okay, वो उसका size है 6 byte. Okay. EU, that is execution unit, will take instruction 1 from this queue. So this queue is basically a bridge between BIU and EU. अगर आपको समझ में आ रहा है तो instruction queue is a bridge between EIU and BIU and EU. So BIU will fill the queue and EU will drain the queue. मतलब एक तरफ से BIU इंस्ट्रक्शन क्यू में फिल करेगा और दूसरी तरफ से EU इंस्ट्रक्शन को क्यू से निकालेगा. And this happens continuously. BIU will say that I will go on filling, and EU will say that I will go on using. That's why that's the critical component in your architecture. When you see your next processor 80386DX, or when you see your next processor that is Pentium, उसमें भी ये क्यू है, सिर्फ उसका साइज अलग है. 8086 में 6 बाइट का है, 80386 में या पेंटियम में इसका साइज थोड़ा बड़ा है, लेकिन सेम कंसेप्ट इज देयर. तो ऐसा नहीं है कि पेंटियम इज समथिंग लाइक रॉकेट साइंस. एवरीथिंग स्टार्ट्स फ्रॉम 8086. All fundamental concepts that we are discussing are used in advanced processors. The only addition is more and more concepts, techniques are added. Okay. Coming back, your BIU will fill this queue with instructions I1, I2, I3, and your EU will drain, use the queue. The moment your instruction 1 is taken by EU, your instruction 2 will come to the position of instruction 1. Your instruction 3 will come to the position of instruction 2. So it's a moving queue. It has to be, because then only some space will be created at the top to bring new instructions. Okay, so it's like a stack, FIFO. FIFO matlab first in, first out. This queue is a FIFO queue. First in, first out. I1 पहले लेके आया BIU ने, EU ने उसको पहले लिया. I2 को बाद में लेके आया, I2 को बाद में लिया. So it is FIFO. So what exactly you are doing in this FIFO? You are putting the instructions and you are taking the instructions. That is what is a fundamental concept of queue. यहां तक अगर कुछ क्वेरी है तो पूछो. We have completed one aspect which is instruction queue. Check it out. Any questions you want to ask? If you have any queries, raise it. ठीक है, let's move on. Okay. Of course, I will not go into EU क्योंकि EU का part we'll be doing further. Still, I will be talking about BIU. Okay. $1 million question is, ये तो ठीक है, इसका तो अभी क्लैरिटी है कि एग्जैक्टली BIU में होता क्या है, फेच और डिकोड एग्जीक्यूट कैसे होता है. बट द $1 million question is that how BIU will understand where in the memory instruction or program is located. Of course, through address bus, no doubt. But for that, in 8086 processor, there is one technique called memory segmentation. So we are going to discuss memory segmentation along with architecture. Okay? क्योंकि ये जो पार्ट है BIU का जो मैंने हाईलाइट किया है, ऑब्जर्व इट. This particular part of BIU support handle memory segmentation. So now we will study memory segmentation along with BIU. Okay? और वो रोल होगा क्योंकि इतना आज नहीं होगा. As per plan, we are going. So we will do memory segmentation discussion halfway and we will continue in session 2 with remaining part of architecture. Okay, but let's go for memory segmentation. Okay, we are in last 30 minutes and I want that you should be alert क्योंकि बहुत ही इंपॉर्टेंट कंसेप्ट अभी हम लोग डिस्कस कर रहे हैं. आपके एग्जाम में इसका बहुत हाई प्रोबेबिलिटी है. मेमोरी सेगमेंटेशन कम्स इन मेनी एग्जाम्स और आपके जो इंटरनल एग्जाम्स है MSc 1 उसमें मेमोरी सेगमेंटेशन तो डेफिनेटली आएगा. दैट्स द प्रोबेबिलिटी. ओके, so let's go for memory segmentation. Here we go. Out of curiosity, can anybody of you share what is memory segmentation in chat box? In very simple words, maybe 4 or 5 words. What is memory segmentation? Since you already started this subject in your institutes. So what is memory segmentation? What you know about it? Anything, anybody? You are. Fine. what is a memory management? 1 MB maximum memory is divided into small logical partitions called segments, such that every segment is 64 KB. 64 KB का मतलब है 64 kilobytes. Okay. And there are 4 types of segments: code segment, data segment, extra segment, and stack segment. Okay. So what is memory segmentation? It's a memory management technique. It is a technique to organize your memory. How? You divide your 1 MB memory into small logical partitions. Every partition is called segment. Size of the segment is 64 KB. It is fixed. Okay, you cannot change this value. And 4 such segments are used in 8086: the code segment, the data segment, extra segment, and stack segment. What it means, okay, let's understand through diagram. Okay, so again a blue box is coming, and that blue box indicates memory called RAM. What we do, and of course this is the architecture for reference, okay, क्योंकि मुझे मैपिंग करना है. What we do, if you see the diagram very carefully, this entire 1 MB memory you divide in logical partitions. You must have seen some colored partitions visible, like in red color, in maroon color, or in yellow color. Okay, so this is one partition called code segment. This is one partition called data segment. This is one partition called extra segment. This is one partition called stack segment. So your microprocessor 8086 do not look at the memory as 1 MB, but it looks at the memory in segments of 64 KB. I again repeat. Okay, let me go back. See this diagram. Your microprocessor, let me mark what I'm talking. This is what I'm talking. Okay, your microprocessor 8086 do not look at the memory as 1 MB. It looks at the memory in terms of segment of 64 KB. Question is why? Okay, why we are dividing our memory into small segments? The answer is, by dividing your memory into small segments, you can better organize your memory. Let me explain. Okay, I'm going to that diagram. Memory segmentation. Okay, what is code segment? Code segment will store only programs. जो भी programs microprocessor को execute करने हैं, those programs you will store in code segment. Data segment. Whatever data your program works, जैसे मुझे 10 numbers को arrange करना है ascending order या descending order में. So your 10 numbers are data that you will store in data segment. Okay. let's not talk extra segment and stack segment immediately. We will only talk code segment and data segment initially, okay, to understand the concept of segmentation. That means you separate your program, that means code and data of that program, into separate parts of the memory. That is called memory segmentation. It means that अगर आपको इंस्ट्रक्शन फेच करना है, ओके, क्योंकि वहां से हम लोग ने आर्किटेक्चर चालू किया था, सी somewhere here, if you want to fetch your instruction, तो मुझे 1 MB मेमोरी तरफ देखने की जरूरत नहीं है, इसको समझो, ओके, उसको बाय हार्ट वगैरह करने से फायदा नहीं है. दिस इज अ कंप्लीट लॉजिकल सब्जेक्ट, इट इज ऑल कंसेप्चुअल, ओके. तो आपको समझ के ही उसको आंसर करना होगा, नहीं तो कोई ऑप्शन नहीं है, फिर यू हैव टू ओनली बाय हार्ट. तो आई इंसिस्ट यू अंडरस्टैंड. See, when you fetch, okay, when you fetch, then instead of looking in 1 MB, now you have to only look into 64 KB. Why? क्योंकि what you fetch instruction. What is instruction? It's a part of the program. And where is the program? Program is in code segment. That means your processor will only focus on code segment. बाकी दूसरी जगह पे देखने की जरूरत ही नहीं है. अगर आपको फेच करना है तो आप सिर्फ कोड सेगमेंट में जाएंगे, बाकी कहीं पे भी नहीं जाएंगे. That is how it is a memory management. Just for your information, 64 KB into 16 is 1 MB. I again repeat, 64 KB into 16 is equal to 1 MB. मतलब 1 MB में टोटल 16 सेगमेंट्स आर पॉसिबल. ऐसे कितने सेगमेंट्स आप बिठा सकते हो? 16 सेगमेंट बैठ सकते हैं. 4 कोड सेगमेंट, 4 डेटा सेगमेंट, 4 एक्स्ट्रा सेगमेंट, 4 स्टैक सेगमेंट, टोटल 16 मैक्स. ओके, दैट मीन्स instead of looking on 1 MB, you are only looking on 64 KB, which is a small part, which is more efficient. That's why we do memory segmentation. So you are only focused on a small part of the memory. आपको 1 MB memory देखने की जरूरत नहीं है. Now imagine as your memory grows, okay, 1 MB मतलब 10 raised to power, मैंने वो पावर्स दिखाए थे, 10 raised to 3, 10 raised to 6. So when your memory becomes in GB, this technique will be more useful, क्योंकि आपका बड़े मेमोरी में आपको छोटा सा पार्ट दिखना है फेचिंग के लिए. That is why this technique is very useful. That is why we divide it into segments, okay, like this. ठीक है, लेकिन इसके साथ अभी कॉम्प्लेक्सिटी आता है. Okay, let me introduce, okay, and then we will summarize. We are in last 1.5. अभी सोचना ये है कि इसके ऊपर काम कैसे करेंगे, क्योंकि ये तो अभी सुनने में वगैरह बहुत अच्छा लगता है कि आप 1 MB मेमोरी लो, उसको छोटे छोटे पार्टीशंस में डिवाइड करो, उसको हम लोग बोलेंगे सेगमेंट. ऐसे 4 टाइप्स के सेगमेंट होंगे: कोड सेगमेंट, डेटा सेगमेंट, एक्स्ट्रा सेगमेंट, स्टैक सेगमेंट. उसमें से 2 हम लोग ने चालू किए, कोड एंड डेटा. तो जितने भी प्रोग्राम्स हैं वो कोड सेगमेंट में रहेंगे, और वो प्रोग्राम का जो डेटा है वो डेटा सेगमेंट में होगा. ओके, तो इट लुक्स गुड क्योंकि आप अच्छे से ऑर्गेनाइज कर रहे हो. बट नाउ द क्वेश्चन इज दैट हाउ माय प्रोसेसर इज गोइंग टू वर्क ऑन दिस. दैट्स द $1 billion क्वेश्चन. वी नीड सम रिसोर्सेस. ओके, नाउ लेट्स अंडरस्टैंड व्हाट वी नीड. Focus for last 15 minutes because this we are going to take it further in session 2. Suppose my processor wants to work on a code segment. Okay, ये जो रेड कलर का छोटा सा बॉक्स मैंने यहाँ पे दिखाया है वो है कोड सेगमेंट. ओके, which is 64 KB, 64 kilobytes. Then processor must know what is the start of this particular code segment. मतलब ये अगर प्रोसेसर को इसके ऊपर काम करना है तो प्रोसेसर को मालूम होना चाहिए ये कहां से शुरू हो रहा है, मतलब ये पॉइंट. अगर प्रोसेसर को डेटा सेगमेंट के ऊपर काम करना है तो प्रोसेसर मस्ट नो वेयर इट स्टार्ट्स. If processor wants to work on extra segment, processor must know where it starts. If processor wants to work on stack segment, processor must know where it starts. That is indicated by a register called segment register. Observe this. Start of the segment is referred using 16-bit register called segment register. मतलब प्रोसेसर के अंदर there will be some registers which are 16-bit, of course 16-bit because your processor is 16-bit, called segment register. Okay, जैसे if I go to the diagram, code segment register CSR will indicate start of code segment. Code segment register, this is a 16-bit register, this will indicate start of code segment. Second, data segment register, which is a 16-bit register, it will indicate start of data segment. Same way, extra segment register, it is a 16-bit register which indicate start of extra segment. And stack segment register, it is a 16-bit register which indicates start of stack segment. So 4 registers are dedicated, one register for one segment: CSR, DSR, ESR, SSR. And these registers will store address where segment starts. जैसे start address for code segment in CSR, start address for data segment DSR, start address of extra segment ESR, start address of stack segment SSR. Okay, and these registers are visible here. Observe it. Can you see these 4 registers? This is ESR. R जो है वो साइलेंट है, वो वहां पे लिखा हुआ नहीं है. ओके, वो समझने के लिए हम लोग R बोल रहे हैं. ESR, extra segment register. CSR, code segment register. Segment register. And DSR, data segment register. These registers are 16-bit registers in BIU. Okay, please understand, this is not extra segment, this is not code segment, this is not stack segment, this is not data segment. ये जो सब सेगमेंट्स है वो यहां पे है मेमोरी में, जो मैंने अभी आपको डायग्राम बताया था. ओके, ऑल दीज सेगमेंट्स आर इन मेमोरी, दैट इज रैम. लेकिन वो सेगमेंट कहां से चालू होते हैं, उसके रजिस्टर्स प्रोसेसर के पास है. ट्राई टू सी द डिजाइन प्रोसेस. आपका सेगमेंटेशन है रैम में, मेमोरी में, लेकिन वो सेगमेंटेशन का जो लॉजिक है वो है प्रोसेसर के अंदर. हाउ? यूजिंग 4 रजिस्टर्स. ESR which indicate start of extra segment memory में, CSR which indicate start of code segment memory में, SSR which indicate start of stack segment memory में, and DSR which indicate start of data segment memory में. ओके तो ऑलवेज रिमेंबर यहाँ पे एक लेटर है R, मतलब वो रजिस्टर्स है. ये 4 रजिस्टर्स है. रजिस्टर का मतलब है स्टोरेज, जहां पे आप कुछ वैल्यू स्टोर कर सकते हो. दैट इज कॉल्ड एज रजिस्टर. REGISTER. ओके ऐसे 4 रजिस्टर्स है BIU में. ESR, CSR, SSR, DSR. One register for one segment. Okay. Now let's continue.
Sir,
And
sir.
add one more parameter. Okay, we are in diagram. This diagram. Okay. Now you focus for last 5 to 7 minutes. I understand that this is bit complex, but we have to keep the pace. अभी सोचना ये है, CSR will tell my 8086 BIU where code segment starts. So my processor will reach code segment using CSR. Okay, let me map in our diagram. Okay, what you want to do? Fetch. What you fetch? Instruction. Instruction is a part of the program, and you store program in code segment. This all I have discussed. That means if my processor wants to fetch the instruction, my processor मतलब है code segment which is 64 KB. Fine. So my BIU will read CSR because CSR code segment register tells what is the start of code segment. So my BIU will read this CSR, and by reading this CSR, my BIU will reach start of code segment, मतलब यहां पे. But now the second question is, my code segment is 64 KB. 64 KB का मतलब है 65536 locations, क्योंकि 2 raised to 16 is 64 KB. Okay, 2 raised to 16 is 64 KB, and 2 raised to 16 if you calculate as a decimal, तो आपको वैल्यू मिलेगा 65536. That means here there are 65536 locations. Which location you want to go in code segment? Because there are thousands of locations. 64 KB. That is called offset. OFFSET. Offset का मतलब है कोड सेगमेंट के अंदर का लोकेशन, उसको बोलते हैं ऑफसेट. And to refer that offset, we use a register called IP. Observe this. IP का मतलब है instruction pointer. IP stands for instruction pointer, which is a 16-bit register. Okay, all registers are 16-bit. This IP indicate which location you want to access inside code segment. मतलब मेरे प्रोसेसर को अगर इंस्ट्रक्शन फेच करना है, तो my processor will read CSR because CSR code segment register will tell start of code segment, and then my processor will read IP instruction pointer because instruction pointer will indicate which location in this code segment you want to refer where there is an instruction. It is called offset. That means your microprocessor 8086, typically BIU, because we are talking about BIU, talks in terms of CSR and IP. ओके, दो अलग अलग रजिस्टर्स प्रोसेसर रेफरेंस के लिए लेता है, CSR जहां पे कोड सेगमेंट चालू होता है, और IP एग्जैक्ट लोकेशन जहां पे मेरा इंस्ट्रक्शन है. दिस इज कॉल्ड लॉजिकल एड्रेस. ये जो एड्रेस है, ये दोनों मिला के ये एड्रेस, इसको हम लोग बोलते हैं लॉजिकल एड्रेस. ओके, and same is applicable for data segment, extra segment and stack segment. वो हम लोग आगे देखेंगे. ओके, लेकिन अभी प्रॉब्लम ये है, ओके, प्रॉब्लम ये है कि लेट मी गो टू द डायग्राम. ओके, ये डायग्राम आर्किटेक्चर. your processor will talk CSR and IP. Observe it. मतलब दो अलग अलग एड्रेसेस प्रोसेसर टॉक्स, स्टार्ट ऑफ सेगमेंट एंड ऑफसेट इन दैट सेगमेंट. लेकिन आपका जो मेमोरी का एड्रेस है वो तो 20 बिट का है, बिकॉज दिस इज एक्सटर्नल. ऑब्जर्व इट, यू आर गोइंग आउटसाइड द प्रोसेसर. सी दिस. And if you are good listeners and if you are alert for our entire session, 2 hours and 10 minutes, then we have said that my 8086 processor has 20-bit address bus. मतलब ये जो एड्रेस बस है वो 20 बिट का है, और आपका जो प्रोसेसर है इट इज टॉकिंग इन टर्म्स ऑफ 16 बिट CSR and 16 bit IP. That means there is a difference what processor talks internally and what processor talks externally. Externally आपका प्रोसेसर 20 बिट एड्रेस बस यूज करता है, और इंटरनली आपका प्रोसेसर दो रजिस्टर यूज करता है, CSR एंड IP. CSR इंडिकेट स्टार्ट ऑफ कोड सेगमेंट जिसमें इंस्ट्रक्शन है, एंड IP इंडिकेट ऑफसेट, एग्जैक्ट लोकेशन इनसाइड कोड सेगमेंट. That means you need some mechanism to convert 16-bit address into 20-bit address, क्योंकि ये जो एड्रेस है वो 16 बिट का है, आपका प्रोसेसर 16 बिट का है. सो ऑल दीज रजिस्टर्स आर 16 बिट, और ये जो एड्रेस है वो 20 बिट का है, क्योंकि आपका जो एड्रेस बस है वो 20 बिट का है. तो यू नीड टू कन्वर्ट 16 बिट एड्रेस into 20 bit address. That is called address translation, and that is done by BIU. ये जो आप सिग्मा देख रहे हो यहाँ पे, हम लोग नेक्स्ट टाइम करेंगे. That sigma stands for summation. There is some calculation that occurs here. इसके लिए उसका शेप ALU जैसा है. Can you see this? This is arithmetic logic unit. उसके जैसा ही यहाँ पे शेप दिख रहा है, because there is some calculation, and that calculation is done by BIU. Okay, that is called address translation, which is the second part of memory segmentation that we will do in next session, next Thursday, 6:30 onwards. Okay, now we will summarize in next 3 minutes. ओके, उसके पहले अगर आपको कुछ क्वेरी है, यू कैन रेज योर क्वेरी बिफोर आई गो एंड समराइज. ओके, सो माय क्वेश्चन इज, एनी क्वेश्चंस?
सर, यहाँ पे जो सी बस में अगर इंस्ट्रक्शन फेच हो रहा है ब्रिज के इधर, तो सबसे पहले ये जो सेकेंड एरो दिखा रहा है ना, वहां पे जाएगा क्या इंस्ट्रक्शन फेच?
सेकंड एरो मतलब
मतलब
वाला
ES,
arrow, ये वाला,
CSR.
ये वाला। See, I am referring by mouse pointer. आप
Yes,
की बात कर रहे हो?
yes, yes, yes.
ये एरो के बारे में मैंने आज कुछ भी बात नहीं किया है. दिस एरो आई हैव नॉट टॉक्ड. आई हैव टॉक्ड अबाउट दिस इंस्ट्रक्शन क्यू. ये जो एरो है इसकी बात हम लोग आगे करेंगे. ओके इसका अभी तक हम लोगों ने कोई रेफरेंस नहीं लिया है. दिस हैज डिफरेंट फंक्शन. दिस
Okay,
एरो आई एम रिफरिंग बाय माउस हैज डिफरेंट फंक्शन. ओके
okay,
रूटीन फंक्शन नहीं है. जो अभी हम लोग ने डिस्कस किया वो रूटीन है. फेच, डिकोड, एग्जीक्यूट. ओके
okay,
उसका नहीं है. वो मैं आपको आगे सिखाऊंगा मेमोरी सेगमेंटेशन में.
okay,
ओके अभी तक हम लोग ने ऑल फंडामेंटल्स ऑफ मेमोरी सेगमेंटेशन किया है. रूटीन प्रोसेस किया है. ओके दैट इज द आंसर टू योर क्वेश्चन. एनीथिंग एल्स यू वांट टू आस्क? प्लीज चेक इट आउट. ओके नाउ लेट मी समराइज. अगर कुछ क्वेश्चंस है तो आप रेज करो. देखो वापस से मैं आपको एक रिमाइंडर देता हूं. ये बहुत वास्ट सब्जेक्ट है. इट्स अ ओशन. आई विल टीच यू ऑल द कंसेप्ट्स but you need to take a lot of efforts. Okay please understand, if you appear for next section next Thursday without any review, without any study, without any revision, तो आपको समझना मुश्किल होगा. मैंने आपको जो सिखाया है वो अच्छे से शांति से 1 घंटा बैठ के रिवाइज करो and then you come for session 2, then only it will be effective. क्योंकि बहुत ही conceptual subject है. तो you need to spend time and you need to revise properly. उसके लिए try to keep some notebook and pen with you. जो important part मैं समझा रहा हूं उसको आपके लैंग्वेज में आप लिखो. नोट्स तो एग्जाम के लिए ऑलरेडी है लेकिन आपको अगर रिवाइज, क्योंकि सी व्हाट इज हैपनिंग, मैं जैसे आपको समझा रहा हूं वो आपको समझ रहा है लेकिन एज द टाइम विल पास आप उसको भूलना चालू करोगे. तो वो सीक्वेंसिंग वो सब आप कहीं ना कहीं आप रखो आपके पास में एंड रिवाइज इट सो दैट दिस इज मोस्ट इफेक्टिव. ओके फाइन. डिफिकल्ट ऑफ कोर्स. ये ऑपरेटिंग सिस्टम, माइक्रो प्रोसेसर, ये सब कंसेप्चुअल सब्जेक्ट्स है. उसमें आपको एफर्ट्स पुटअप करना ही पड़ेगा. इसीलिए तो आपका कंप्यूटर चलता है. इट इज सो डिफिकल्ट. दैट्स व्हाई योर माइक्रो प्रोसेसर एंड प्रैक्टिकल एग्जाम नहीं है. डोंट वरी. इसमें फाइनल प्रैक्टिकल एग्जाम नहीं है. ओके दैट इज अ थोड़ा ब्रीदिंग स्पेस है. तो अच्छे से समझना जरूरी है. ओके दैट इज द आंसर टू यश. Anyway, I think now we can stop for the day. We'll continue next Thursday, okay, with continuation. Okay, thank you so much. That was a good start. से एफर्ट्स करो. बहुत इंपॉर्टेंट सब्जेक्ट है. आपका जो कंप्यूटर है ये इसके ऊपर चलता है. तो ऐसा मत करो कि कॉम्प्लेक्स है इसके लिए छोड़ दिया करके. टेक एफर्ट्स. ओके Anyway, let's continue next time. Thank you so much. Have a nice weekend. We'll continue next Thursday. Thanks a lot. Anybody in the office, you can end the session and session is complete. Thank you.
Okay, sir. Good night. Thank you.
Bye bye. Good night. Thank you.
Bye, sir.